What is nuclear energy's role in space exploration? Imagine a power source so reliable it can operate in the cold, dark depths of space for decades without needing sunlight. That's what nuclear energy offers for space missions. And like solar power, which depends on sunlight, nuclear energy can provide consistent power even in shadowed regions of the Moon or Mars. This makes it ideal for long-term exploration and establishing bases on distant planets. Nuclear energy in space mainly comes from two sources. The first is radioactive decay, which powers radioisotope thermoelectric generators, or RTGS. These devices convert heat from radioactive materials into electricity. RTGS have been used on many space probes and rovers, like the Voyager spacecraft and the Mars Curiosity rover. They can produce power for over 30 years without needing sunlight, making them perfect for missions to faraway planets or shadowed areas. The second source is nuclear fission reactors. These reactors split atoms in a controlled way to produce heat. This heat can then be turned into electricity or used directly for propulsion. Small nuclear fission reactors have been tested in space, providing power for satellites and potentially for future crewed missions. They generate a lot of heat through nuclear reactions, which can be converted into electrical energy or used to propel spacecraft faster and more efficiently than chemical rockets. From a thermodynamics point of view, nuclear systems in space convert nuclear energy from decay or fission into heat. This heat then transfers through materials, following heat transfer principles, to produce electrical power or thrust. This process involves managing heat flow carefully to keep spacecraft components at the right temperature and minimize energy losses. Practically, nuclear energy helps power spacecraft instruments and life support systems in places where solar power isn't enough. It also provides heat through radioisotope heater units to keep spacecraft warm in the cold vacuum of space. Nuclear thermal propulsion uses heat from nuclear reactions to generate thrust, offering higher efficiency and faster travel times. This can cut months off journeys to Mars or other distant destinations. Long-term human habitats on the Moon or Mars also relying on nuclear energy. It supplies steady power and heat, supporting life systems and enabling humans to stay longer and explore more. In essence, nuclear energy helps space missions go farther, last longer, and operate more reliably. It is grounded in thermodynamics principles, converting heat into useful energy, and overcoming the limits of solar power. This makes it a key player in the future of space exploration, helping us reach new worlds and establish a presence beyond Earth.